Hello, Brigadiers! This is Kent Rancourt, one of the Brigade project maintainers. We've recently welcomed a lot of new contributors to our community, and we are so happy about that. We've been noticing that a lot of the new contributors are students, or early in career developers, who could use a little help getting started with Git, or more specifically, a little help getting started with the very particular ways that our project, and most other CNCF projects, use Git. So this video is a tutorial that hopefully demystifies things. Two basic things we're not going to cover today are what Git is and how to install it. We're going to assume that you know what it is and that you have already installed it or are capable of doing so. What we will talk about today are the typical workflow for making a contribution to our project and signing your commits. This includes both a DCO sign-off and a cryptographic signature. Although we didn't talk about what Git is, there's one very important fundamental aspect of Git that we do need to discuss, and that's the fact that it's a distributed version control system. Emphasis on the word distributed. So the workflow we're going to demonstrate today, which is a fairly typical one, involves three repositories, essentially three copies of the same code base. These three copies include the official Brigade repository that lives in the Brigade core org in GitHub, your fork of that official repository that lives in your own GitHub account, and a local working copy of that code on your machine. These three will not always be perfectly synced up with one another, and that's okay. We're going to talk about the relationship between these three things and how you can sync up the specific things that you're working on. Here's an example repository that I've created under the Brigade core org on GitHub. This is the repository that we want to contribute to for our tutorial today. The first step in doing so is forking the repository. In the upper right-hand corner of the screen, you can see a fork button. Click on that. If you have access to create new repositories in more than one account or organization, a dialog will ask you under which one you want to create your fork. You're typically going to choose your own personal account, so that's what I'll do here by selecting Crankcore. That's me. This takes a few seconds to complete, but when you're done, you have an exact copy of the repository that now lives under your own GitHub account. The next thing we want to do is clone the repository. This is where things can be a little confusing. There are a lot of different ways that you could approach this. However we choose to approach it, we're going to want the same result in the end. So I'm going to show you first what we're looking to achieve, and then I'll show you the path that I usually take to get there. What we want is a local copy of the code that is connected to both the official repository we're trying to commit to and our fork of that repository. Why? We want to be connected to the official repository because we will periodically want to sync its latest changes to our local copy of the code, so that when we make changes ourselves, we're using the most up-to-date code as our starting point. We will not have adequate permissions to write our changes directly to the official repository, and even if we could, we would still want our changes subjected to the usual code review process. So we will want to write our changes to our fork instead. Once the changes we want to make are present in our fork, we'll be able to open pull requests so that project maintainers have the opportunity to review the proposed changes. In the Git CLI, each of the remote repositories we want to connect to, both the official one and our fork, are literally called remotes. So we're going to want to associate two remotes with our local working copy of the code. People have different preferences for the names they give to their remotes. I'll show you how I like to do it. I like the remote for the official repository to be named Upstream. I like the remote for my fork to be named Origin. You do not have to use this same naming scheme. Whatever you do is fine as long as it makes sense to you. For the purposes of this tutorial, we'll stick with the scheme I just described. One important thing to note is that unless you want to dive into the different flags and options available in the git clone command, the remote repository you clone from is automatically going to be named origin. I mentioned that I personally like the remote named origin to point to my fork. That being the case, my fork is what I'm going to clone. Over in my browser, the page we're sitting on here is the page for my fork. Click the green code button, and in the section under clone, you can pick either HTTPS or SSH. I feel like SSH is generally the more convenient option, but it's only going to work if you've already uploaded the public half of your SSH key to GitHub. We're not going to cover that today, but we'll assume this is something you're capable of accomplishing on your own. So I'm going to pick the SSH option here. Click the button to the right of the URL to copy it to your clipboard. Now, in your terminal, you can type git clone followed by the URL that you just copied. You may notice that the URL for my fork ends in hello git 3. That's because I forked this repository a few times already today in preparing for this tutorial. I don't want my local working copy of the code to be named hello git 3, so I can add an additional argument to override that name. You can skip this if it's not applicable to you. This will copy your fork down to a new hello git directory. Let's change into that directory. If we list our remotes using the verbose or V flag, we'll be able to see that we do now have a remote named origin, and it points to our fork. Recall that we also want a connection to the official repository. So back in the browser, in the upper left-hand corner of the screen, I'll click the Brigade Core Hello Git link. This returns me to the official repository. Here, I'm going to repeat the steps of clicking the green code button and copying the URL. Now, back in the terminal, we'll add a second remote. Git remote add. We'll use the name upstream and follow that with the URL for the official repository. If we list our remotes again, we'll see we now have 2. We've already alluded to the typical workflow, but it's important enough to bear repeating. We're typically going to sync the latest changes from upstream to our local copy, and we're going to sync the latest changes from our local copy to our fork, also known as origin. We'll open PRs that propose changes from our fork be synced with the official repo. If we overlay specific Git terminology over this conceptual understanding, we want to pull changes from the official upstream repository, and we want to push changes to our fork, origin. Then we will PR changes from our fork to the official repository. Let's demonstrate all of this by making a small change to the readme.md file. The first thing we want to do is make sure we're using the very latest code from the official repository as our starting point. We do that by typing git pull upstream main. This syncs the latest changes from the official repository's main branch to the local repository's main branch. Since we just set up this clone, there aren't really going to be any changes that need to be synced right now, but it's a very good habit to get into using this command before you start new work. Now ideally, we'd like to keep the main branch perfectly synced to the official repository, so we're not going to make changes directly in this branch. Instead, we'll create a new branch that's a copy of this main branch, and we'll apply our changes there. We might often refer to such a branch as a feature branch. Let's first be very certain that we're currently sitting on the main branch. I'm going to type git branch. These are all the branches that exist locally. At the moment, we have just the one. The branch denoted with an asterisk is the one we're currently on. You might also notice that the name of the current branch also appears in my shell prompt. We won't be covering how to do that, especially because it depends on which shell you're using, but I do highly recommend researching how to set that up, because it'll help to avoid a lot of mistakes that can happen if you thought you were working on one branch, but were actually on another. If you want to switch between branches, you can always type git checkout followed by the branch name. We don't actually have any other branches right now, so I won't submit this command. At the moment, we're sitting on the main branch, and we want to make a copy of that branch. To do that, we also use the git checkout command, but we add the -b flag to indicate that this is a new branch. We're planning on making some edits to the readme.md file, so I'm going to name my new branch readme updates. This command has both created a new branch and switched us onto it. If we type git branch again, we can see the asterisk now sits next to the name readme updates, denoting that this is the branch we're currently sitting on. Again, my shell prompt shows me this all the time. Now we'll get down to the real business of making the changes that we want to make. I'm going to make some small edits to the readme.md file and save those changes. Back in the terminal, we can use the following command to inspect the ways in which our current branch is now divergent from the main branch that it was based on. You can see the M next to the readme.md file denotes that this file has been modified. If we want to commit this change, we can use the command git add readme.md. This stages the modifications we made to that file for inclusion in the commit we're about to make. If we want to see that it is indeed staged now, we can query the status again. Now it's time to commit. We always have to include a description in a commit to describe the changes. If we type git commit without using the message flag, the default text editor, in my case Vim, will open and give you the opportunity to craft your message. I like to bypass the editor when I can by using that flag, and immediately follow it with a description of the change enclosed in quotes. Be aware that depending on what characters are in your message, you may have to use single quotes rather than double quotes to ensure your shell takes the message verbatim and doesn't try to perform substitutions and such. You can see that this commit failed, and for good reason. Git needs to know your name and email address because this information is always automatically included in every commit. If you want to see what Git thinks your name and email address are, you can use these commands. Git config user.name. In this case, Git does not know my name. Git config user.email. Git also does not know my email address. You can set these for the current repository by using these commands and then adding the name and email address you wish to use. If you want to apply these settings globally, so they're used by all repositories you work with, you can use these same commands with the additional global flag. This is one-time setup. Now I'll attempt my commit again. Now that the work is committed, I can push it to my fork, otherwise known as the origin remote. From this point forward, things get substantially easier. You can use GitHub's command line interface to open a PR, and that is something you can explore on your own if it interests you. but you can pretty easily open pull requests from GitHub's web UI as well, and that's what I tend to do. In my browser, I can visit either the official repository or my fork. I'll refresh this page, and you can see that GitHub shows me it's aware of a new branch that I have recently pushed to my fork, and it's inviting me to open a new pull request. I'll click this button, and the rest of the process is pretty self-explanatory. The PR automatically inherits its title from your commit message. If you have multiple commits on your branch, the title is inherited from the branch's name. You can change the title if you want. Just make sure it's something that will adequately and succinctly convey to a maintainer what the change is that you're proposing. Put more detail in the description and make sure you're telling the maintainer everything you think they should know before they review your request. There's one especially helpful thing that you can add to the description that is a very big help to maintainers. You can add the text "fixes" followed by an issue number at the top of the description. And that will automatically make GitHub associate your PR with a documented issue. If and when your PR is merged, the associated issue will automatically be closed. This spares maintainers from having to manually close issues that have been adequately addressed. It's not actually applicable in this case because no issues currently exist in this repository. Now I'm going to switch into the role of maintainer for a moment and review this PR. It looks good to me, so I'm going to merge it. Now let's suppose that you want to work on another new feature. Back in our terminal, let's return ourselves to the main branch. I mentioned before that it's always a good practice to sync the latest changes from the official repository's main branch to your local main branch before you start new work. And in this case, since you just watched me merge a PR, we actually know there are changes in the official repository. So let's be sure we've got them. Now we've got the latest changes, and we can proceed with creating a new branch for our next feature. I'm going to end this section of the tutorial by mentioning that if you're not completely synced up before starting new work, or if a maintainer merges new changes into the official repository while you're busy working on your own changes, there are ways of syncing your feature branch with the latest changes from the official repository without starting all over again. It's an advanced topic, and we're not going to talk about it today. I'd encourage viewers to learn about this themselves when it becomes relevant. I'll at least point you in the right direction by suggesting that the term you might want to research is called rebasing. Rebasing is also a technique that you can use to amend your commits with additional changes, change the order that your commits are applied, squash multiple commits together, and so forth. So again, I highly suggest learning about rebasing at some point in the near future. Now that we've discussed the typical workflow, we'll talk about two specific types of signatures that the Brigade project requires to be applied to every commit. They are the DCO sign-off and a cryptographic signature. Why two signatures? The two signatures address two different concerns. The DCO sign-off is a simple attestation by the contributor that they believe they are legally permitted to make the contribution they're offering. It's basically a way of saying, neither my government nor my employer would have a problem with this. I'm not offering you anything illegal or proprietary. The Cloud Native Computing Foundation, which governs the Brigade project and many others, requires commits to bear such a signature. Fortunately, adding this signature to your commits is very easy to do, as we will see shortly. The cryptographic signature, on the other hand, is something the Brigade project has elected on its own to require. As viewers may have observed, there's been an increased focus over the past year or so on securing the so-called software supply chain. That's a complex topic, so we're not going to go too deep into it. but cryptographically signing your commits helps GitHub, and therefore us, to more strongly associate all contributions with their original author. Knowing for certain who is responsible for each and every commit to Brigade, and being able to prove that cryptographically, is one of the first of many steps still to come in securing the software supply chain. Before we go any farther, I'm going to introduce the concept of branch protections. These are GitHub configuration settings that a project's maintainers may apply in order to enforce certain policies that commits and pull requests must comply with. In my browser, I'm going to visit the settings for the upstream repository and create some protections for the main branch. The settings I'm going to apply here are typical of the various repositories under the Brigade project. First, we'll require a status check to pass before merging. The particular status check we want to pass is the DCO check. This will require that all commits bear the DCO sign-off. I'm also going to check require signed commits. Obviously, the term signature is somewhat overloaded here, but by clicking this checkbox, I'm requesting that every commit bears a cryptographic signature. I'm now going to return to the PR that we created earlier and have already merged. If we visit the Checks tab, we'll notice that the check that validates that every commit bears a DCO sign-off did not pass. That was okay for our first PR because that branch protection was not in place at the time. Now that it is, we'll have to make sure that all future commits include a DCO sign-off. Now we'll talk about how to do that. Let's make another commit. Since our branch protections now require it, this time we'll make sure we include a DCO sign-off. On the new branch that we created not long ago, let's modify the readme.md file once more. We'll stage the file for commit as before. This time, when we commit, we'll leave off the M flag so that our default text editor will pop up and interactively collect our commit message. On the last line of the message, I'm going to include the following text. Note that you need to use your real name and the same email address that you configured the git CLI with earlier. If we look at our commit history using the git log command, we can see the sign-off text is now included. What I've just demonstrated is that the DCO sign-off isn't magic. It's nothing more than a specific chunk of text that you can add manually to your commit messages. Personally, I find this an inconvenient method of performing DCO sign-off because I can never recall the exact format of the text that I'm supposed to use. There is an easier way. Using a command that I'm not going to explain or ask you to understand right now, I'm going to undo our last commit and show you the easy way. If we use the git status command again, we can see that we've undone the commit, but the modified readme.md file is already staged and ready for us to try our commit again. This time we'll add the sign-off or small s flag. Once again, using git log to examine commit history, we can now see that DCO sign-off text was automatically added to the end of this commit. Once again, using a command I'm neither going to explain nor ask you to understand, I will undo the last commit. Then we're going to do the commit again and purposefully leave off the DCO sign-off. Why? So I can show you how to easily add the sign-off to an existing commit if you have at first forgotten it. Using git log, we can see that the DCO sign-off text is missing. Let's go as far as to push this mistake to our fork and open a new PR. Here we can see that the DCO sign-off check has failed. Back in our terminal, let's fix this. We'll use the command git commit amend, and we'll add the S flag. Once again, using the git log command, we can verify that the DCO sign-off text is present. This has fixed the commit locally, but I still need to push it up to my fork. We can see that this has failed. Essentially, the push has been rejected because this change doesn't build on top of what's already out there in the My Next Feature branch of my fork. I want to replace what's there instead of just layering more changes on top of it. This is easy enough to do by adding the force or F flag to the push command. GitHub is pretty smart, so when we update the branch that our PR is based on, the PR itself is automatically updated. If we return to our browser and look at the PR again, we can see that we're now passing the DCO sign-off check. If we look carefully now, we'll see that GitHub still doesn't want this PR to be merged because the commit still hasn't met the requirement of being cryptographically signed. Fixing that is going to require us to generate a GPG key and configure the Git CLI to use that for cryptographically signing all of our commits. We'll also have to upload the public half of that key to GitHub. I'll be transparent that this is the hardest part of the whole setup, but fortunately, it's strictly a one-time thing. Once this is set up, all of your commits to every repository you work on will automatically be cryptographically signed. Before we really dive into this, I'm also going to offer a disclaimer that I'm going to walk you through the most basic setup possible. There is a wide range of additional measures that can be applied to ensure the private half of your GPG key is absolutely private and invulnerable to theft. For instance, I generated my own key on an air-gapped device, then transferred it to a YUBIKEY, which is a tiny bit of physical hardware for securely storing keys. I moved that YUBIKEY over to my laptop when I was done. The key actually remains on the YUBIKEY hardware and actually cannot be copied off of it. When I cryptographically sign a commit, the signing operation is actually carried out on the YUBIKEY and not on my laptop. The end result is that no copy of my private key has ever existed on a machine that is connected to the internet. There has been no opportunity at all for it to be stolen, and that means I'm extremely confident that no one can cryptographically impersonate me. I actually do recommend that people explore taking such precautions, but the setup is just too involved for me to walk you through right now. So here's the basic setup. First, you'll need to make sure GPG is installed. We're not going to cover this here because the installation process varies from one operating system to the next, but it should generally be available from your operating system's package manager without too much fuss. All the commands we're going to show require GPG 2.1.17 or higher, and if your OS is up to date, that shouldn't really be a problem. The first thing we're going to do is list all the private keys we have available with which we can sign our commits. We'll use the following command. In my case, you see several keys I have previously generated. If you just installed GPG or are using it for the first time, you won't see any keys in this list. If you do see a key here that you want to use for signing your commits, you can skip the next few steps. Assuming the list that you saw was empty, or you didn't see the key you wish to use, we're going to move on to generating a new one. This is an interactive process. Select option number 1, or whichever option says RSA and RSA. Now we're asked to specify a length for the key. Use at least 4096. Next, specify an expiration date for your key. I'm going to choose 0, which indicates that the key will not expire. Next, we're asked to provide our real name and our email address. Last, we're asked to provide a comment. This helps you identify your key later on. I'm just going to use the text demo. Now specify a passphrase for your key. This helps keep your private key secure, so that even if it is stolen, the chances of it being used are lower. Now that our key has been generated, we will list the available keys once again. Here we see the demo key that I just created. Next, we want to identify the ID of the key that we want to use for cryptographically signing our commits. You can find this by finding the line that starts with SEC. Look for the string to the right of the /. This is the key's identifier. Copy it. Now let's configure the Git CLI to use this key to cryptographically sign our commits. Note that this process is very similar to what we used much earlier in this tutorial to configure the Git CLI with our name and email address. As with your name and email address, you can also use the global flag if you want to apply this setting to all repositories instead of just this one. I'm also going to configure Git to automatically cryptographically sign all commits. And once again, you can use the global flag to apply this configuration setting globally. This takes care of our local setup, but because this is a form of public key cryptography, we need to upload the public half of our key to GitHub, or else GitHub will have no way to verify our signature. Let's export the public key. We will once again use the key ID that we copied earlier. We'll now copy the output of the command, beginning with begin PGP public key block and ending with end PGP public key block. Then we'll visit github.com/settings/keys. We'll click the button that says New GPG Key, and we'll paste the text that we just copied, and click Add GPG Key. Back in our terminal, we're going to amend our last commit, which, if you recall, was not cryptographically signed. We don't want to make any changes to the commit message, so we'll just exit the editor. Git will prompt us for the passphrase we selected earlier in order to temporarily unlock our private key and use it for signing this commit. Now we can force push to our fork. In our browser, we can pull up our recent PR and see that the one commit it contains now includes both of the necessary signatures. We have passed the DCO sign-off, and if we look at the commits, we can see that this commit is verified. The maintainer who reviews your PR may now have feedback on the technical content of the PR, but all necessary signatures are accounted for. The Brigade maintainers hope that this tutorial has been helpful, and we look forward to working with you all.